G'day everyone, welcome to another Wandelbots NOVA tutorial series. Today we're jumping into Python. My name's Jayden and I'm joined here by the man, the myth, the legend, Naveed.
Super excited to be here as always, my good man. So, should we get started?
We shall.
So, you guys can see my screen. This is basically going to be your entry point to Nova, right? This is the first thing you see when you click on your instance, whether it's cloud or it's local. And what we are going to do is not focus on this, but rather focus on the Python code today. So what I did was I prepared a few robots for us, which we will move, specifically the UR10E. So let's quickly jump to the robot pad. Now, before jumping into the technical depth of the Python code, Jayden, what do you think so far?
I do have a question for you, and I was going to say, as a Python user, how easy is it to set up?
So, as a Python user, it was actually quite nice because I could already take the experiences that I have with Python and transfer them into using Nova and start moving the robots. Because the Python SDK, it already comes with a set of examples. And as a developer myself, from personal experience, I feel like seeing examples are one of the best ways to know and learn something new.
Yeah.
And we have multiple examples out there.
Perfect.
Awesome. Guys, let's dive into the code. Initially, we have a few import statements here. Again, if you're a Python developer, you know what these are. But just to clarify, these are basically our Nova SDK libraries that we will use for ease of movement of the robots. So let's look at the main file right now. So we instantiate this class called Nova with the host URL and the access token. However, you can specify the host URL and the access token inside a .env file, and then just read the environment variables from there. For now, I am specifying this right here. Keep in mind, if your instance is locally installed, you do not need the access token. Cool. And then we specify our cell. If you have multiple cells, you can specify which cell you want to work with. For now, I only have one cell, and I'm signifying that. And then, which is the main part, which is we specify our controller. So here we have UR10E, and that is the controller that you see right here. And I specified that because that is the one I will currently show you guys how to move. Now, before I get into the movement part, Jayden, halfway through the code, what do you think?
Yeah, it looks pretty easy to go around. And I just wanted to ask your overall learning curve here.
So, like I said, in terms of learning, I was able to transfer a lot of my prior experience with Python. The example files helped massively for me. And again, yeah, you always need to do some trial and error method when you're moving the robot, right? And that's always the case for everybody. But other than that, it was a very low learning curve for me.
Perfect.
Awesome, guys. Now let's get into the interesting part. Let's get into moving the robots, right? So over here, we are going to specify the controller as 0 because our motion group right here is 0. And then we specify the home joints. This is basically the current joint of our robot and the TCP. So right now, for me at least, I only have one TCP, which is why I specify the first of the list. But of course, if you have multiple TCPs, you can specify this here in order to select a different one. And now we come to the most important part, which is for how to move the robots, right? So we have an action list right here. And this signifies how the robot should move. For example, it's going to do a joint movement to its home joint. Then it's going to do a P2P movement to its target pose. For now, I specify the target pose as just a 1 unit movement in the X direction. This symbol right here just signifies a matrix multiplication. After that, we move again to the home position with a joint movement, and then a P2P movement in 50 units in the X direction, and then back to home, 50 units and 100 units in the X and Y direction, and then 50 units in the Y direction. Then we specify the velocity for each of those movements, each of these actions that we have specified right here. You can give each of the actions a different velocity. For now, I am giving all of them a value of 100. We then plan the trajectory. So if your trajectory of the robot is not possible, this is where you get a failed trajectory planning, failed exception right here. And this becomes very important because, of course, before the robot collides with anything, we would want to see what the planning trajectory of the robot looks like before actually executing this with a real robot. And then finally, we execute the robot. Now, before I run the script, Jayden, So far, so good.
Yes, so far so good. I do want to ask a question about dependencies. So what about the dependencies for using Nova SDK?
That's a very good question. So for now, we actually have a pyproject.toml file that comes with our SDK. All you have to do is do a poetry install or a UV sync, and this should get things running on your local machine.
Perfect.
Awesome. Let's get into it. Let's do an execution of this file. And it's executed. If you look at here, you see the robot is already moving without any Wandel script, without any external robot controller. It's solely on Python.
Perfect. That's what we want to see. Well, there you go, guys. There's a quick overview of a tutorial on using Python in Nova. And just before we go, Naveed has a little bit extra that he wants to show you.
Yeah, let's consider this a teaser for the next tutorial, because we are going to show you how we use Python to visualize the trajectories of the robot, how we use Python to create our own collision world around the robot, to see a nice little way of what exactly will happen with the trajectories that we have planned. So the example right now I'm showing you guys is a small welding example. Again, everything done is using Python and rerun right here. Something we will go over in the next tutorial. Until then, that's it from me.
Wow, there you go, guys. A little bit of an insight to the next video. Until then, we'll see you later. Catch ya.